Same thing with our second graph. So we are going to graph this one, but we're going to need to create a table. So here that is. And again, we want to pick values for x that are both positive and negative. So we're going to choose -2, -1, 0, 1, and 2. So notice we picked more values here because this is not a graph we've seen before. Now, anytime you see an x squared graph, that's typically going to look like a u. So we're going to substitute the values in like we did for the last problem. So x equals -2, y equals -2 squared plus 2. That's equal to 6. And when x is equal to -1, y equals -1 squared plus 2 is equal to 3. When we do the same thing for 0, we'll get 2. And the good thing about this type of graph is that it is symmetrical. So when we do it for 1, the y value is 3 and 6. So what we can do is we can graph this also on the same website. So I'm going to turn the previous one off. And this one we're going to graph as x squared plus 2. We're going to press the graph button. And we get the following. It's called a parabola. Now on this parabola, when we're trying to find out the domains, we're trying to find out how far to left does this graph go and how far right does this graph go. So I'm going to change our colors just a sec so it's easier to see. Notice that as we trail this graph or trace this graph going to the left, it's going up, but that's irrelevant because we want just the x values or left or right values. So as we go to the left, it's going to continue to go on forever, and if we go to the right, same thing. So what we can say is the domain is all real numbers. For our number 3, same idea. We would select our values, and this time we're going to graph it. So the unfortunate thing is that it doesn't appear like this graph, or this will graph absolute value signs. So I'm going to graph one for you. When we do this type of graph, it actually turns out to look like a V. So our graph will be a V like so. And again, as this graph goes to the left and to the right, notice it's going to go on infinitely long. Therefore, the domain is also all real numbers. So let's try another set of problems. Number 1, 2, and 3 says find the range of each function for the domain -4, 1, and 3. So when they give us a predefined domain, in this case it's 3 different values, all we're really going to have to do is substitute those values in for x and see what we get. So y equals 2 times -4 plus 4. That tells us that y is equal to -4. When we do the second one for x equals 1, we get y equals 2 times 1 plus 4. That tells us y is equal to 6. For x equals 3, we get y equals 2 times 3 plus 4. That tells us that y is equal to 10. Therefore, when it asks us to find the range, we would say our range equals, and we can use these 2 squiggly brackets and say that it's -4, 6, and 10. And the reason why we know is because as we substituted those values for x in, these are our y's. So same thing applies for number 2. Notice we have function notation for 2 and 3. this is again to help us determine which function or which graph we're referring to. So x equals -4. We have f of, instead of x, it's -4, right? So f of -4 equals 4 times -4 minus 5. F of -4 turns out to be -21. Same thing for x equals 1. We get f of 1 equals 4 times 1 minus 5. So f of 1 equals -1. Same thing for 3, x equals 3. F of 3 equals 4 times 3 minus 5, which is 7. Therefore, our range for the second one is -21, -1, and 7. Last but not least, we have h of x equals 1/4 x plus 1x. So x equals -4. We get h of -4 equals 1/4 times 4 plus 1 times 4. 1/4 times 4 turns out to be 1 plus 1 times 4 is 4. Therefore, we have 5. Next one, x equals 1. H of 1 equals 1/4 x, or 1/4 1, plus 1 times 1. H of 1 turns out to be 5/4. Let's try the last one. X equals 3. We get h of 3 equals 1/4 times 3 plus 1 times 3. H of 3 is equal to 3/4 plus 3, which is 15/4. Now it's your turn. I'd like for you to try these two problems, and when you're done, post your answers to iMiddle. First person will start, everyone else will just reply. That's all for now. See you next time.